phrase scientia potentia est is a Latin aphorism meaning knowledge is power, and it's commonly attributed to the English philosopher Sir Francis Bacon. Hello viewers, I am pleased to bring knowledge to you on the program Science Education Half Hour with Udume Chibueze. My name is Priscilla Iwurum. Here on Television Nigerian, Udume Chibueze has made science subject a lot simple for students who have challenges in the subject. So, what are you waiting for? Go grab a pen and a notebook and come to the classroom.
Welcome to today's edition of Science Half Hour. The subject of today is chemistry, and the topic of today is group and period. We know that electronic configuration is the arrangement of electrons in the atomic shares. What is group? Group is the numbers of electrons in the atomic shares, while period is the numbers of shares in which electrons occupy in atom. For you to be able to know the group and the period of that element, what you need to do is to carry out electronic configuration. After the electronic configuration, the numbers of electrons found in the atomic shares is the group, while the numbers of shares or orbit in which the electrons occupies in that atom is called the period. For example, let's consider hydrogen. The symbol of hydrogen is H. The atomic numbers of hydrogen is 1. Note that we use electron to carry out electronic configurations, and the numbers of electrons is equal to the numbers of protons, and numbers of protons is equal to numbers of atomic number, and therefore we use the atomic number to carry out the electronic configuration, because in neutral atom the numbers of protons is equal to the numbers of electrons. So the numbers of electrons in hydrogen is 1. That is, atomic numbers of hydrogen is 1, which is atomic number is equals to 1. This is an orbit. So the electronic configuration of hydrogen is 1. And the numbers of electrons found in the atomic shares is 1. Meaning group, this hydrogen belongs to group 1. And the period, how many orbit is here? We have only 1 orbit. Meaning period is 1. So hydrogen belongs to group 1 and period 1. Let's consider boron, B. The atomic numbers of boron is 5. Now, what is the group of boron and what is the period of boron? Why is this topic important? The topic is very, very important because before you can prepare periodic table, you must know the group and the period in which the element belong. And in preparing for WAEC, NECO, GC examination or Jamb, you are likely going to meet this question every year. Question number 1, where you can calculate the group and the period of that element. That is why you have to take this topic very, very serious if you want to obtain A1 in your examination. So now let's talk about this boron. The atomic numbers of boron is 5. We are going to configure this boron, which is going to be 1, 2. The first orbit will take 2 electrons, as it was discussed during our previous lessons. We discussed about the numbers of electrons in which each orbit can take. So this is K share, it will take 2 electrons, and L shares will take 8 electrons. So if this K share has taken 2 electrons, the numbers of electrons remaining is 3. That is 5 minus 2, making 3. So we put the remaining 3 in this orbit. Now after that, how many electrons is in this outermost shells? This is the inner, this is the outermost. The outermost shell electron determines the numbers of groups. So how many electrons is inside these outermost shells? It's 3. 1, 2, 3. Meaning that boron belongs to group 3. Then how many orbits is this electron occupying? There are 2 orbits. 1, 2. That is period 2. Group 3, period 2. 1, 2, 3. Group 3. 1, 2, period 2. Let's consider sodium. The symbol of sodium is Na. An atomic number of sodium is 11. To carry out electronic configuration of this sodium, so that we can know the group and the period of this sodium, we have it to be like this. 1, 2. This K will take 2, L will take 8. Then 11 minus 2 is 9. This orbit will take 8 electron. So remaining 1 electron, and then this third orbit will take the 1 electron. Now, what is the group? The group is the numbers of electrons in the outermost orbit. Then what is period? Period is the numbers of orbits in which the electrons occupy in that atom, which is 1, 2, 3. If you have understood this and understood this, please can you tell me the group of this sodium and the period of this sodium? That is, the numbers of electrons in that atmosphere here is 1, which is group 1. Then the numbers of orbits is 3. 1, 2, 3, meaning period 3. So, sodium belongs to group 1 and period 3. Another example we're going to consider. Let's consider oxygen. Let's consider oxygen. The symbol of oxygen is O, and the atomic number of oxygen is 8. Then the electronic configuration of this oxygen is going to be 1, 2, 3, 4, 5, 6, 7, 8. Total numbers of electrons, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then what is the group of this element and what is the period of the element? Let's count. 1, 2, 3, 4, 5, 6. The numbers of electrons in this outermost orbit is 6. So group is group 6. And the numbers of orbit is 2. 1, 2. That is period 2. That's good. You shall be wise. Let's consider chlorine. The symbol of chlorine is Cl, and the atomic numbers of chlorine is 17. Then we have the electronic configuration of this chlorine as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's good. Now the question is, what is the group of this chlorine and what is the period of this chlorine? Let's count. To get the group, we'll consider the outermost orbit. This is the outermost orbit. The group, let's count the numbers of electrons there. 1, 2, 3, 4, 5, 6, 7. Numbers of electrons in the outermost orbit is 7. So group 7. Let's consider the numbers of orbits there, which is 1, 2, 3, meaning period 3. Very good. Let's also consider another example. Let's consider calcium. The symbol of calcium is Ca. The atomic numbers of calcium is 20. we are going to carry out electronic configuration of this cation, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How many electrons is found in this outermost orbit? There are 2 electrons in this outermost orbit, meaning group 2. So the group of cation is 2. How many orbits do we have in this electronic configuration of cation? There are 4 orbits. Let's count. 1, 2, 3, 4. Meaning period 4. Period is equals to 4. I hope you are following. I won't like you to fail the question whenever you come across on how to get the group and the period of the element. If you don't know the group and the period of the element, what you have to do is to take the atomic number given to you and carry out electronic configuration. At the end of the electronic configuration, the numbers of electrons in the outermost shell is the group, while the numbers of orbits of that element is the period. Let's consider phosphorus. The symbol of phosphorus is P, and the atomic numbers of phosphorus is 15. Let's carry out the electronic configuration of this phosphorus, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's complete. Now, how many electrons is in the outermost orbit? Let's count. 1, 2, 3, 4, 5. 5 electrons, meaning group is equals to 5. How many orbit is here? Let's count. 1, 2, 3, meaning period 3. That's good. I want to consider the last example. Let's talk about argon. The symbol of argon is Ar, and the atomic numbers of argon is 18. Is 18. The atomic numbers of argon is 18. We have it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Complete. So what is the group of this argon? Let's count the numbers of electrons in the outermost shells. 1, 2, 3, 4, 5, 6, 7, 8. So this one belongs to group 8. Normally, if you have anyone that belongs to group 8, you equally say that it belongs to group 0 or group 0. Why is it group 0? Because the element cannot give out electron and cannot accept electron. We call such element noble gas. So then what is the period of this argon? The period is 1, 2, 3, period 3. I want to understand that this electronic configuration, sometimes we want to test your knowledge to find out if you know the numbers of electrons occupied by that element, or if you also know the group and the period from that element. They will give you electronic configurations using the SPD notation. Then I want to also show you how you can get the SPD notation, how you can be able to get the group and the period from the SPD notation. SPDF notation. Now I want to understand that this S, the maximum numbers of electrons for this S is 2, and the maximum numbers of electrons occupied by this P is 6. The maximum numbers of electrons occupied by this D is 10, and the maximum numbers of electrons occupied by this F orbit is 14. Now, what is group? As we earlier said, and period. Group is the numbers of electrons found in the outermost shares, while period is the numbers of electrons in which the electrons occupies in that element. During the SPD notation, the coefficients of the last S is the period, while the power of the last S is the group. But if P is at the front of the last S, we add the power of P to that of the last S to have the group of that element. For example, 1s2, 2s2, 2p6, 3x1. Is this the last X? No. Is this the last S? Yes. To get the group of the element, what you have to do is to consider the last S. And also, if you want to know the period, you consider the last S. The last S tells us valence orbit. The last S tells us the valence orbit. Now this is the valence orbit here, and that is where the group and the periods are found. For example, the power of the last S is 1, meaning group 1. The group is equal to 1. Now the coefficients of the last S is 3. The coefficient is 3, which is period 3. This is the group. This is the period. The power of the last S is the group, while the coefficients of the last S is the period of that element. If you consider the numbers of powers here will tell you the number of atomic number or the numbers of electrons of that element. Let's count it. 2 plus 2, 4 plus 6, 10 plus 1, 11. So the atomic number of this element is 11, and which means that this element is sodium, atomic number being equal to 11. Remember, we did the electronic configuration as this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the numbers of electrons in this outermost shell is 1, which is group 1. And the numbers of orbit here is 3, 1, 2, 3, meaning period 3. So the power of the last S is the group, and the coefficients of the last S is the period. Do you understand? Yes, you shall be wise. Let's go on. Now let's consider this again. 1s2, 2s2, 2p6, 3s2, 3p6, 4x2. Now the question is, what is the group of this element and what is the period? You don't know this name of the element. You don't know the element, but you don't care to know, because the question is, what is the group and what is the period? What you have to do is to know the power of the last S and also to know the coefficients of the last S. The power of the last S tells you the group, and the coefficients of the last S tells you the period. So how many electron is at the top of the last S? Is 2. So group is group 2, and period is equals to the coefficient of the last S, which is 4. If you want to know the number of the element, you can add the powers. The powers will be able to tell you the atomic number, then you can be able to know the name of the element. Let's add together. 2 plus 2, 4 plus 6, give you 10. 10 plus 2, 12. 12 plus 6, 18. And 18 plus 2, 20. That's good, which means this element here is calcium. We remember that we did the electronic configuration of calcium and obtained the period and the group. Group being 2 and period equals to 4. Let's also still compare it again. We have it to be something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So how many numbers of electrons is in this outermost orbit? Which is 2. 1, 2. meaning group 2. And how many obit is this? Is 4. 1, 2, 3, 4, meaning period 4. So power of the last S is the group 2. Coefficients of the last S is 4, meaning group period 4. Period 4 here. Then group 2, 1, 2, the power here. I don't want you to fail the question because you are going to meet it during examination. I want to pay attention to understand this. That is how we go about it. Now, if we have electronic coefficient as this, 1s raised to power 2. The group of this element is 2. What about the period? The period is what? 1. Group 2, period 1. If you have something like the 1s2, 2x1. What is the group and what is the period? The group is group 1 and the period is period 2. You are there, you are getting it. So if we consider this one, 1s2, 2s2, 2p5. Correct. What is the group of this one? And what is the period of this one? The group is not group 5, neither group 2, but the period is period 2. I told you to get the group when it's being found at the atomic shell. If P is at the front of the atomic shells, what you need to do is to add the power of P to that of the last S to get the group of that element. Let's do it now. Now, because of P is at the front of the last S, we consider the whole of this place to be the valence electron. Consider the whole of this place to be the valence electron because P is at the front of the last S. So let's add. If you want to get the group, you add the power of the last S, which is group is equals to 2 plus 5 gives you what? 7. And period remains the coefficients of the last X, the period 2. Let's find out the name of this element. 2 plus 2, 4 plus 5 gives you 9. So the name of this element is fluorine. So which is fluorine? The symbol of fluorine is F, and the atomic numbers of fluorine is 9. If we configure this fluorine, we are going to have it to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now, how many electrons is in this atom's orbit? We count it 1, 2, 3, 4, 5, 6, 7. That is 2 plus 5, 7. Group 7. How many orbit is here? Let's count 1, 2, which is 2, meaning the coefficients of the last S is 2. Very good. Let me test you again. Can I get this one? One S2, 2S2, 2P6, 3S2, 3P4. Good. Let me find out if you can get this one. The answer is 2 plus 4 equals to 6. So group is group 6. And period is equals to period what? 3. You are there. Please remember to subscribe to our YouTube channel to get more video.
Welcome back. Trust you had an impactful lecture. Thank you so much for watching. For adverts and sponsorship considerations, please contact the following phone numbers: 090-9670-6251 or 090-2159-9127 or 080-3362-8945. You can also follow us on our social media handle. Our Facebook page is TV Nigerian. You can also tweet at us at TV Nigerian. Instagram is TV Nigerian. You can also email us, and our email address is info@tvn.news. Please subscribe to our YouTube channel to get our latest videos. Our YouTube handle is Television Nigerian. Thank you for watching.
Welcome to Living Treasures Academy. Enjoy a conducive and serene learning environment. Qualified and experienced teachers. Equipped computer laboratory and library. Secured atmosphere. Extracurricular activities. An all-embracing curriculum for total development of the child. Comprehensive education for leadership. Join us today from crèche to secondary levels. Living Treasures Academy, committed to excellence.